All right, we should be recording now. Hello, everyone. This is going to be the exam one review for Saini's Math 176 section. My name is Michael. I'm going to be the tutor leading this session. And yeah, I guess we should just go ahead and get right into it. So let me go ahead and clear that off the top there. Let's see, I'm ready to use annotations. There we go. So yeah. So for these, I don't know if I'll have a chance to get through all of them. I'll try and get through as many as I can. And yeah, feel free, if you have any questions, feel free to leave questions in the comments, or you can also come to the Math Center if there's a question on this review sheet that I don't go over. So yeah, let's go ahead and let's just do number 1 to start. So for number 1, it wants us to find the derivative using the rules of differentiation. And I assume that this doesn't mean by the definition, because with doing all of these by the definition would be a little bit crazy. So we'll just do it using normal rules of differentiation. For any constant, if you want to differentiate any constant, do d by dx of any constant, say c. This is always going to be 0. And the reason is because when you have a constant function, that when you take the derivative, it's basically just the slope. And you think about the graph of a constant function, say, I don't know, y equals 3. We'll just have a function that looks like this. And you can see that this is completely horizontal, meaning that the slope is going to be 0. So that's why this is going to be 0. So that's just something good to keep in mind. It'll come up again throughout this review sheet. All right, so let me go ahead and erase that. So that was number 1. Now moving on to number 2. So for number 2, let me go ahead and switch colors. It wants us to find the derivative of the function f by using the rules of differentiation. And this is going to take advantage of the general polynomial rule. So if we have some polynomial, say x to the n, and we want to take the derivative, so we want to do d by dx of this, this is going to end up being, so we'll have n times x to the n minus 1. So an example of this would be, say, if we wanted to differentiate x squared, that would just be 2x. The exponent comes down, and then you subtract 1, and that becomes your new exponent over here. All right. And also, one final rule before we get into these is that if you are taking the derivative of a constant times a function, say d by dx of some constant c times some function f of x, that's just simply going to be, we can pull this constant to the outside of our derivative, so it'll be c times the derivative of our function. Or I guess if you wanted to be a little more concise with your notation, you could say c times f prime of x. All right, so with these concepts in mind, we can go ahead and evaluate this derivative. So we want to find d by dx of 9x to the 8th. So to do that, we can bring the 9 out front, and we'll have 9 times d by dx of x to the 8th power. And then we're going to use that same rule up top here. Next kind of looks like an alpha. Let me fix that really quick. Dx. All right. So we'll bring this 8 down to the front, and then we'll subtract 1 to get 7. That'll be our new exponent. So we'll have 9 times 8, x to the 7th, and I believe 9 times 8 is 72. So 72 x to the 7th, like this. All right. Number 3 is going to be pretty much exactly the same. You'll follow the same process and should get a pretty similar answer. So I think I'm going to go ahead and skip over that one and let you guys try that one out. So let me go ahead and clear these drawings, and we can move on to number 4. All right, so number 4. I'll go ahead and switch colors again. We'll do some in green, excuse me. All right. So they give us our function here, f of x is equal to 25x to the 1/5, and they want us to find f prime of x using the rules of differentiation. So this, we're going to use the exact same rule with our polynomials, where if we have x to the n, we're going to take n to the front, and then we'll have the new exponent will be n minus 1. So I'll write this over here. So f of x is going to be 25x to the 1/5. So what we're going to do is to find f prime. It's going to be, so I'm going to bring the 25 to the outside. So I'll write 25 times d by dx of x to the 1/5. All right, so now from here, we're going to bring the 1/5 to the front, subtract 1. Or if we were to make this common denominator, it'd be 1/5 minus, and then 1 multiplied by 5/5, we get 5/5. It'll be minus 4/5. All right, so we'll have 25 times 1/5 times x to the minus 4/5, which is just 5 times x to the minus 4/5, like this. So yeah, hopefully I didn't make any arithmetic mistakes there. I'm not really seeing any. So yeah, that's how you do that. The fractional power is just the same as the normal ones, where we have to use our power rule to get the derivative. All right. So now from here, yeah, I think we'll have enough time to do number 5 as well. Let me go ahead and double check. Yes, we are recording. All right, so let me go ahead and clear these drawings and we can move on to number 5. So for number 5, it wants us to find the derivative using the rules of differentiation again. I don't know why I keep saying that, but yeah. And so here what we're going to do is we can do the same thing as before, but we factor out the constant. So we'll have f prime of x is going to be 11/10 times d by dx of x to the 10/11, just like that. Bring the exponent down to the front, subtract 1, or in this case, 11/11. If you were to get a common denominator, we'll get minus 1/11. And then you'll actually see that this simplifies quite nicely because we have 11/10, and then we have 10/11 that we're multiplying by. So these are going to cancel out. And we'll just be left with x to the minus 1/11, just like this. All right, so that should be about it for number 5. All right, and then let's see. Yeah, we'll do number 6 as well. Number 6 is a good one. So let me go ahead and clear these drawings, and I will go ahead and switch colors, get some nice light blue going on here. And let's get to number 6. All right, cool. So for number 6, it wants us to differentiate f of x is equal to 9 root x. So for this, all we have to do is remember what root x is, or I guess in a more general form, you could say something like this. So if we have the nth root of x to the m, this is going to be the same thing as x to the m over n, like this. Just kind of different ways you can notate square roots or just roots in general for x. So in this case, the root doesn't have any indice. That means that it's square root, so n is going to be 2, and x is just the first power underneath the square root, so m is going to be 1. So this is just going to be the same thing as 9 times x to the 1/2. And then from here, we can just use our power rule. So we'll just be subtracting 1 here, or 2/2, and bring down the 1/2 to the front, and we'll be left with minus 1/2 up here. So we'll have 9 divided by 2 times x to the minus 1/2. You can leave it like this as a perfectly fine answer, but another way to write it is to bring this x to the minus 1/2 into the denominator and also rewrite it as a square root. So what we can rewrite it as 9/2 square root of x, like this. Yeah, so either way, I think WebAssign should take either answer. I don't think your professor should be too picky on that, but just another way to write that answer. All right, and then here you may have noticed that I didn't actually factor out the constant, and in this case, it's okay to just leave it like this and multiply by that, because that's what would have happened anyways if we were to factor it out. So kind of just skipping a step there. So yeah, that should be your answer for that one. Let me double check and make sure I didn't miss a negative sign or anything. I think we are good. All right. Cool. So I'm going to go ahead and clear these, and we can move on to the next one. All right. Yeah, number 7 is definitely a good one to go over as well. So we'll go ahead and do number 7 really quick. So for number 7, it wants us to find the derivative again with the rules of differentiation. And again, we have this polynomial x to a power, but this time it's a negative power. So this can sometimes throw people off. We have to remember the definition. So if we want to do the derivative of some x to the n, it's going to be n times x to the n minus 1. So a common mistake students will make is they will just say, oh, well, this is going to be whatever the constants turn out to be times x to the minus 7. But that's not actually going to be the case, because remember, when in this exponent, it's going to be n minus 1, not n plus 1. This would be the case if it was n plus 1. When we subtract 1 from a negative number, it makes it more negative. I guess. So, and then with this in mind, what we can do is we can do a similar thing with our power rule. So we'll bring our exponent down, subtract 1, and it'll be -9, not -7. So we'll have -8, -1, -9, and negative. So we'll have -8 times 5, x to the -9, which is just going to be -40, x to the -9, just like that. So yeah, you just have to be careful there. Make sure you're subtracting 1, not adding 1 with the exponent, and you should be good to go. All right, so I think actually should be good to leave that up there for a little bit, and we can move on to number 8. So number 8, let's see, what do I want to do for number 8? We'll do pink, why not? So we want to find the derivative again, and we're given f of x. So these are similar to some previous problems, except now we just have some functions being added and subtracted from each other here. We can use the exact same rules, because with derivatives, if you have a few functions, say we want to take the derivative of some f of x minus g of x. Why do I keep writing alphas? Let me make sure that's an x here. Plus h of x. This is just going to be, we can kind of distribute the derivative. So we'll have d by dx of f of x minus d by dx g of x plus d by dx h of x. Like this. I don't know why I keep writing alphas. I think I'm writing too fast. I need to slow it down a little bit. I'll try and do that. H of x and d by dx there. All right. Yeah, so we just have to take the derivative term by term. So if we look at our first term here, this 3x cubed, we could factor out the 3, and d by dx of, I guess I'll put f prime of x is equal to, and then derivative of x cubed, and then minus, I'll factor out of -9 from the next one, d by dx x squared, plus d by dx of 3. Perfect. All right, so then from here, we'll have 3, and then the derivative of x cubed. Remember, bring this down. We'll have 3 times x squared, because 3 minus 1 is 2. And the next one, we'll have minus 9 times 2x. And then this last one, remember what we said before, derivative of constant is just 0, so this goes to 0, so there's no need to even write anything at the end. All right, so bring these constants in, we should end up with 9x squared minus 18x. Just like this. And I guess technically, if you wanted to be fancy, you could factor out a 9x and it'd be 9x times x minus 9, but I don't think there's really need to do that. This is a perfectly fine answer right there. All right, so that's a quick example of I guess where you have a sum of some different polynomial functions. Number 9 is extremely similar, so I think I'll leave that one to you guys to practice. And I'm going to go ahead and clear all of these drawings, and we can move on to number, let's see, yeah, number 10. Number 10 will be good to practice so we can get some more fractional powers in. All right, let's go ahead. I'll stick with purple, not purple, pink for now. So I want to find the derivative of the function f by using the rules differentiation. I don't know why I keep saying that. Using differentiation. So we're given f of x is 9x to the 4th minus 3x to the 7/2 plus 8. So we're just going to use the similar power rules. So for our first term with 9x to the 4th, we're going to bring the 4 down and then subtract 1. So we should just be left with 36x cubed, because 4 times 9 is 36. And then the next one, I'm actually going to do a side. So I'll just say a side. Derivative of 3x to the 7/2. So the derivative of this, we're just going to subtract 1 or 2/2 and get 5/2 and bring down the 7/2. So we'll have 7/2 times 3x to the 5/2. And multiplying this together, we'll get 21/2 times x to the 5/2. Just like that. All right, so 21/2 x to the 5/2. And then again, derivative of a constant here, derivative of this 8 is just going to be 0, so no need to write anything. Yeah, and then from here, I don't think there's really any valuable simplification you can do here, so I think this is a perfectly fine answer. Cool. All right, number 11 is pretty similar, just a little more complicated with some of those fractions, but should be a similar process to number 10. So I think I'm going to go ahead and skip over that one, and we can move on to number 12. So I'll leave this up here for a little bit longer, then we'll clear it and move on to 12. All right. Go ahead and clear those. Zoom was having a moment. All right, cool. So now we'll go ahead and switch to this purple for number 12. Let me scroll down. So for number 12, we'll just find the derivative again, where this is our function. We have f of x is equal to 9 over x cubed minus 9 over x squared minus 1 over x plus 250. And then for this, we're going to have to remember some exponent rules. So if we have some 1 over x to, say, the a, 1 over x to the a, we can rewrite this as x to the minus a. We can bring this x to the numerator and then write it as x to the minus a. So that's what I'm going to do here to start, because it's not really the easiest to take a derivative when we don't have the form x to the n. So we'll go ahead and enforce this form for the terms. So we'll have this is equal to, so we'll have 9 x to the minus 3 minus 9 x to the minus 2 minus x to the minus 1, and still plus 250 on the end. All right, so this is our f of x. Now from here, we can just apply our power rule, being careful with the negative signs. So in doing that, we'll have f prime of x. So for the first term, bring down the minus 3. So minus 3 times minus 9, that's minus 27 x, and then subtract 1 from the power, we get minus 4. And then the next one, bring down the minus 2. Minus 2 times minus 9, that's positive 18. And then subtract 1 from the minus 2, we get x to the minus 3. And then for the last term, minus 1 times a minus out front is going to give us positive x, and then the power is going to be minus 1, which is minus 2. And then at the end here, we just have a constant, and the derivative of constant is still just 0, so no need to write anything extra there. So yeah, that should be about it for all the calculus here. And you could rewrite this as, say, minus 27 over x to the 4th plus 18 over x cubed plus 1 over x squared. But I think either answer is perfectly fine. If you want to leave it in this form with the negative exponents, I think that should be a perfectly fine answer, because I don't think WebAssign is too picky on the formatting there. So yeah, that about wraps it up for number 12. Let me go ahead. I think I actually may have just enough room to do number 13. So I think I might as well do that right about now. So for number 13, it's pretty similar, except we do have one small difference with the powers here. So for the first term, it's going to be really similar to number 12. We're bringing it up to the top and make it negative. So we'll have 4x to the minus 4, like this for our first term. So this function is equal to 4x to the minus 4 minus, and then we'll have 2x to the minus 1/2, just like this, because that property holds even for fractions. And now from here, we're just going to do the same old power rule. So bring down the minus 4 with the first one, minus 16, x to the minus 5. The next one will bring down our minus 2, and then minus 1/2. So we'll have minus 2 times minus 1/2, which is just positive 1. So we'll have plus, and then just x, and then our power is going to be minus 1/2 minus 1, or minus 2/2, which gives us negative 3/2, I believe. All right. Minus 3/2, just like that, and that should be your answer, as long as I did all the arithmetic correctly. I am going through these fairly quickly because we do have quite a few to go over. I think there's 50 in total, so I want to get through as many as possible, but yeah. All right, cool. We'll go ahead and leave that up there for just a hair longer, and then we can move on to the next one. All right. Cool. Oh shoot, forgot to clear my drawings here. All right, clear those, then we'll scroll down. All right, so number 14. Number 14, and let me go ahead, I'll switch to a different color again. So we'll have, so it says find the derivative again, and we're given this function. Let's see. Well, this is actually going to be very similar to number 13, because we have the square root in the denominator. Remember from before, square root is just x to the 1/2, so it'll be a very similar process to 13. So I think we'll actually skip over that one and move on to 15 instead, so we get into some of the other rules here. So up to this point, it's been mainly power rule when we're taking the derivatives of some constants and that sort of thing. This is where we get to our first new rule called the product rule. And for this, what the rule is if we're taking the derivative of some function f times another function g, this is going to be the derivative of the first function times the second function plus the derivative of the second function times just the original first function, like this. And we see here we have a product of two functions, an x squared and x minus 2. So we can just plug right into this formula, where in this case our f of x, well, I guess kind of a bad example with using f of x when f of x was already used from the start, but where our f of x in this formula is 9x squared and the g of x is x minus 2. So what we have to do is differentiate the first one, so f prime of x, the derivative of 9x squared is just going to be 18x, and then multiply it by our original g, which is x minus 2. And then we can add the derivative of the second one. The derivative of x minus 2, well, that's just going to be, well, derivative of x is just 1. So we'll have 1, and then the derivative of negative 2 is just constant, so it's just going to be 0, so no need to worry about that. And then from there, we'll have just multiplying by original f of x, which is 9x squared. All right, so I'll go ahead and multiply this out. This is probably a fine answer here to put into WebAssign, but I'm going to do a little bit of simplification just for the sake of example. So we'll have 18x squared minus 18 times minus 2, that's going to be minus 36x plus 9x squared, and then combining like terms, you get 27x squared minus 36x. And you may be thinking, this is definitely one way to calculate this derivative, and it's kind of a good example of how the product rule works. But another way you could do it is if you were to distribute this 9x squared into both terms, then you could just differentiate it term by term like we were doing before. So I guess let me go ahead and write other way. That's going to be to distribute this in. So if we distribute it in, we'll get 9x cubed minus 18x squared. And then if we just do our normal power rule, let's see, 9 times 3, that's 27x squared. And then for this second term, if we differentiate that, we'll get the minus 18 times 2 minus 36x. Exactly the same as here. So that's also a good way to double check your answer if you can do that in this case. So yeah, that was number 15. Number 16 is going to be similar, except this time we just have a product of two linear functions. So you could do it either way. You could multiply it out, or you could use the product rule, or you could even do both to double check yourself. So I think I'll leave that one for you guys to practice. So I'll go ahead and include this, and we can move on to number 17. Let's see. All right. So for number 17, I will do this one. I'll do a little bit of a lighter blue, I guess. So we're going to be using the same product rule. So this is going to be our f of x. This is going to be our g of x. So for the first term, it's going to be f prime times g. So we'll take the derivative of our first function. So the derivative of x plus 1, that's just going to be 1. And then the derivative of, oh shoot, no, it's just multiplied by the original second function. Don't multiply the two derivatives. That's definitely something that can happen if you're going too fast. All right, so there's those two, and then we're going to add the derivative of the second function is going to be, what is that, 18, not 18, 16. I wrote 16, but I said 18, sorry about that. 16x minus 3, and then we'll multiply by our original f, x plus 1. All right, perfect. So now from here, 1 times x squared, 1 times 8x squared minus 3x plus 9, that's just going to be 8x squared minus 3x plus 9. Excuse me, losing my voice. And plus, and then if you're entering this into WebAssign, you can probably just leave it just like this. But you could multiply this out and maybe do some simplification. Some terms may cancel, but I think this is a perfectly fine answer. If you wanted to double check your answer by, say, foiling this out and then differentiating term by term, you would have to multiply this result out from product rule to double check your answer. But yeah. That should be it for number 17. So we'll go ahead and leave that up there. Actually, I think number 18 is going to be kind of similar to the other ones, except this time we have some higher order polynomials instead of just linear ones. So I think I'll leave that for you guys to practice. Remember to use the power rule and remember the product rule as well, and you should be good to go for that one. So I'll go ahead and include these drawings, and we can move on to, let's see. Yeah, let's do number 19. Might as well. All right, so for number 19, I'll just differentiate this function right here. So again, this is going to be another product rule. So it's going to be the derivative of the first function here. So the derivative of the first function, that's going to be, so I'll put f prime. This is equal to, so 3x squared plus 9. And then times the original second function, 3 plus 1 over x squared, plus, and then we take the derivative of our second function. So that's just going to be, well, the 3 goes away. And so the second term, x to the minus 2, bring the minus 2 down and subtract 1. So we'll have minus 2x to the minus 3 multiplied by our original first function, x cubed plus 9x plus 9. And then from here, I think I'll go through with the simplification on this. This is probably a fine answer here, but I'll go through with the simplification because there's a few nice things that cancel out. So I'll go ahead and start foiling these out. So for this first one, it'll be 9x squared, these two, and then these two, it'll be plus 3. And then these two, 9 times 3 is 27, and these two plus 9 over x squared. All right, so this next one, we'll have, let's see, the first term distributing in here, we'll have minus 2 because x to the minus 3 times x to the 3, that's the same thing as x cubed over x cubed, which is just going to give us 1. So minus 2 plus, oh shoot, never mind, minus 18 over, oh shoot, I'm jumping ahead. X to the minus 3 times x, that's just going to be x to the minus 2, which is just 1 over x squared. So we'll have 18 over x squared like this. And then finally, minus 18 over x cubed, or x to the minus 3. All right, and then from here, we can go ahead and combine some like terms. So we'll have 9x squared, and then plus 3 plus 27, that's going to be 30, minus 2, that's 28, plus 28. And then here we have a plus 9 over x squared, minus 18 over x squared, so minus 9 over x squared, minus 18 over x cubed, like this. So yeah, as long as I've done that arithmetic correctly, that should be your answer for number 19. Yeah, so I'm gonna go ahead and clear that. That should be it for that one. And we can move on to the next one. So let's move on to number 20. Number 20 wants us to find the derivative of this function g. G of x is equal to 3 over 5x plus 6 plus 6x squared. So for this one, there's actually a couple different ways you can do it, but we'll probably just do it with quotient rule because it'll be a good, easy example of quotient rule. So quotient rule, if I can spell quotient, hopefully, quotient, I think, rule. So the quotient rule states, so if we have the derivative, if we want to take the derivative of f of x over, I'll put h of x this time because we have g of x in our original here. This is going to be the derivative of the top function. Oh my goodness. The derivative of the top function times the bottom function minus, this is what's different from the product rule, minus the derivative of the bottom function times the original top function all over the bottom function squared, like that. So now for this one, we're going to differentiate term by term, looking at this term first, then this term. So for that term, our top function is going to be 3. So f of x is 3, h of x is 5x plus 6, and then f prime of x is just going to be 0, and h prime of x is just going to be 5. So now we can just plug everything in. So we'll have the first term, we'll have 0 times our original h of x, so 5x plus 6, minus h prime of x is 5 times our original f of x, 3, all divided by h of x squared. So 5x plus 6 all squared. This term goes away, and the minus 5 times 3 is going to be minus 15, all over 5x plus 6 squared. Like that. Oh, shoot. Don't circle it just yet. Can't remember. That was the first term. We still have one more term on the outside here where we have to do our normal power rule, the plus 6x squared. So the derivative of that is just going to be 12x. And now we can circle the answer, and we should be good. So yeah, I think that is looking good. So let me go ahead and clear that. That's a pretty basic example of the quotient rule. Let's see what other quotient rule problems we have going on down here. All right, I think I'm going to leave number 21 for you guys to practice. It's not quite as easy as the quotient rule for number 20, but you have to keep in mind that formula, and you should be good to go, making sure you plug everything in correctly. But I will do number 22. So let's look at number 22. So for that one, let's see, let's do this in dark green. So for this one, our top function is going to be x. So I guess it's kind of difficult with notation because the one function they call g of x, I'm calling it f of x again. So I guess I'll just I can just call them top and bottom. So we'll have the derivative. So for the first term in our quotient rule, we'll have the derivative at the top, which is just 1 times the original bottom, root x plus 9, minus derivative of the bottom is going to be, what is that? So remember root x, x to the 1/2, minus 1 is minus 1/2, bring this to the front. So we have 1 over 2 root x from before. So let's see, 1 over 2 root x times the original top x. All right, and then in the denominator, we just have our bottom squared. Like this. All right, so doing a little bit of simplification, we have root x plus 9. Oh, and also, I think I may have forgot to say for the first one, this is probably a totally fine answer here. You can put in the WebAssign, but this does simplify fairly nicely, so I think I'm going to go through the simplification. All right, and then from here, we get minus, I'm going to write the 1/2 on the outside, and then on the inside, we'll just have x divided by root x, and x divided by root x, that's just going to give you root x, like this, all divided by root x plus 9 squared. This is going to be equal to, so root x minus 1/2 root x is just going to be 1/2 root x plus 9, all divided by root x plus 9 squared. And then from there, you could multiply numerator and denominator by 2 to get rid of the fraction on the root x, but I think this is a perfectly fine answer. So yeah, I'm going to go ahead and circle it here and then end it off there. Don't think there's too much else, too much other simplification you could do in this case. All right, so now I think that's about going to wrap it up for 22. Let's see, I'm debating whether I want to do 23 or not. See, 23 is going to be really similar to kind of like we had a similar product rule example with x plus 1 and some other functions, so it shouldn't be too bad to evaluate. So I think I'm going to leave that one to you guys to practice, and I'll do another quotient rule. Let's see, is there any more quotient rules down the line, actually? Let me check really quick. I think it's mainly just chain rule after that. So, actually, what I'll do is I'll do number 23 and I'll skip 25. I'll do that. All right, get my annotations back. All right, so 23, we're just going to be plugging into the formula. So the derivative of the top is just 1, so we'll have 1 times the bottom, and then x squared plus 9x plus 3. There, this is f prime of x. And then from there, we have minus, and then derivative of the bottom function. It's going to be, what is that, 18x plus 9. And then times the original top, x plus 1, all divided by 9x squared plus 9x plus 3, all squared. And then from here, you could do some simplification. It might factor nicely, and you may be able to cancel something out towards the end. But at this point, all the calculus is done, and it's just simplifying. So I think I'm going to leave the simplifications up to you guys and just go with this as the answer here. All right, so that should be it for number 23. So I'll go ahead and actually, I'll just leave it up for now, and we can move on to 24. Let's see. So 24 is going to be another product rule, or actually, you know what? I actually don't think I've done an example yet where we multiply it out. So let's do an example where we multiply it out. Let's FOIL this out and just differentiate it term by term. So we'll multiply these two and then these two. So we'll have 9x to the 4th minus 9x plus 2x squared minus 2 over x. And we're taking the derivative of this. So the derivative of this, bring the 4 down, we'll end up with 36x cubed. I think we may have actually differentiated that exact term before. Minus 9 plus 4x, and then let's see, the derivative of this last one, remember, so we'll have minus 2x to the minus 1, bring the minus 1 down, and subtract 1, we'll get minus 2. So we'll have plus 2x to the minus 2, or if we were to just rearrange this a little bit, 36x cubed plus 4x minus 9 plus 2 over x squared, just like this. So yeah, and then this answer should be perfectly fine, but that's just a way to make it look a little bit nicer. So yeah, that should be it for number 24. Let me go ahead and clear all of these drawings and we can move on. Like I said before, I'm going to go ahead and leave 25 to you guys and you can move on to number 26. And number 26 is our first introduction to the chain rule. So the chain rule concerns composite functions. So if we want to take the derivative of some function f of g of x, like this, a composition of functions, this is going to be equal to, let's see, I think I got my parentheses right there. Yep. This is going to be equal to the derivative of the outside function evaluated at the original g of x times the derivative of the inside g of x, or g prime of x, like this. I don't know why I put 2 parentheses there. Should just be 1, like that. All right. So for these sorts of problems, it's a good idea to try to identify what is your outer function, what's your f of x, and what's your g of x. Or I guess in this case, you could call the outer function h of x because we've already defined the whole function to be f of x. So in this case, our outer function, or h of x, let me go ahead. I'm actually going to replace all these f's with h's just to hopefully stay away from any confusion there. So h of g of x and then h prime. So so we know here, if we look at our outer function, so the outer power is just 9, and we're going to have some input into that exponent. So our outer function should just be h of x equals x to the 9th, just like that. And our inner function is just going to be what's on the inside here. So this 9 minus x. So g of x is just going to be 9 minus x, like that. All right, so now we'll do h prime of x. So h prime of x here is going to be 9x to the 8th. I think this is actually on the first problem that we did. We took the derivative of this, but kind of got to it here, so that's kind of funny. And then we'll get the derivative of the inside, g prime of x, which is just going to be minus 1 because the 9 goes away because it's a constant. All right, cool. So now from here, we just have to be careful to plug everything in correctly. So this is h prime of x here that we've calculated, but we don't want h prime of x. We want h prime evaluated at g of x, our original function. So to accomplish that, all we have to do is take our 9 minus x and put it in where we see an x here and our h prime of x. So this is just going to be, so h prime of g of x, that's going to be equal to 9 times 9 minus x all to the 8th power. All right, and then from here, all we have to do is multiply by g prime of x, which is just minus, oh shoot, did I? Yes, I did make a mistake. G prime of x shouldn't be minus x, it should be just minus 1 because we just have x to the first power here. So it should just be minus 1. So for a final answer, I think it's okay just to write it as minus 9 minus x to the 8th power. Doing this big multiplication, multiplying out this binomial isn't really going to result in any meaningful simplification. So I think this is a perfectly fine answer right here. All right. I'm gonna get a sip of water really quick, and then we can move on to the next chain rule one. All right. Cool, so moving on to number 27. I think I'll do one more of these, and then if there's any ones that are similar like this, I'll probably let you guys practice. So we'll have, so with this, we have 9 times x cubed minus x all to the 4th power. So what we're gonna do is use this formula, but I'll do it in a little bit of a quicker way. So what we're going to do is bring this 4 down and multiply it by the 9 and subtract 1 to get our 3. So it's kind of like power rule, right? So we'll get 36 out front times x cubed minus x all to the 3rd power. Don't forget we have to multiply by the derivative of the inside, which is going to be 3x squared minus 1 in this case. And that should be, I think that's good enough for your final answer. So that's a little bit of a quicker way to go about the chain rule, but it can be good to double check your answers and keep good tabulation of your different functions and the derivatives and all that sort of stuff. All right, so I'm going to go ahead and clear these drawings, and we can move on to the next one. All right, let's see. I'm going to go ahead and skip over 28, and we can look at, let's see, we can look at number 29 and 30. All right. So for number 29, finding the derivative again, and we have 10 over x squared minus 9 to the fourth power. And there's actually a couple different ways to go about this one. So we can either evaluate the derivative as is using the quotient rule, or a cool trick we can do is we can bring this x squared minus 9 to the top, to the numerator, by making that exponent negative. So we can equate this as 10 times x squared minus 9, all to the minus 4 power, and we can differentiate it using the chain rule. So let's go ahead and do it like that. Feel free to use the quotient rule to double check me, or to double check your own answers. That's a good way, like on an exam, if you're unsure and you get a problem like this, you can always differentiate it using the chain rule and also the quotient rule to double check yourself. All right, so for this, bring down the minus 4, subtract 1 to get minus 5. So we get, let's see, 10 times minus 4 times x squared minus 9, all to the minus 5 power, multiplied by the derivative of the inside, which in this case is just going to be 2x. Perfect. All right. 10 times minus 4 is minus 40. Minus 40 times 2 is minus 80. So we'll have negative 80 times x squared minus 9, all to the minus 5 power. And you could rewrite this as minus 80x over x squared minus 9, all to the 5th power, but I think this answer up here is perfectly fine. Like that. All right. And then let's see. Actually, now that I think about it, I think number 30 will be a good one for you guys to practice on. It's going to be very similar to number 29, except for instead of just a number power, like to the 4th power, we have a fraction power with the square root. So it'll be a similar principle, except we'll have to deal with that fraction when we do power rule in the chain rule. All right, so I'm going to go ahead and erase all of this, and we can move on to the next one. Yeah, let's see. I think I'm actually going to leave 31 for you guys to practice as well, and I'll do the fractional power this time on 32. So on 32, again, I'm just going to quickly rewrite this as 8x plus 9 over 8x minus 9, all to the 1/2. And now we can go ahead and move on with our chain rule. So we'll subtract 1 from the power here. This is equal to minus 1/2. Bring the 1/2 to the front. So we'll have 1/2 times 8x plus 9 over 8x minus 9, all to the minus 1/2. And then, yes, we have to multiply by the derivative of the inside. And yes, we have to use the quotient rule. So we'll go ahead and do that. So the derivative of the top is going to just be 8 times just the original bottom, like this, minus the derivative of the bottom is just going to be 8, just like the top, and then the top 8x plus 9. All divided by the bottom squared, 8x minus 9, all squared like this. And for this, you could go through, multiply these 8s through, simplify that numerator, maybe move this, let's see, 8x plus 9 over 8x minus 9 to the minus 1/2 to the denominator, and try and do some more simplification there. But I think at this point, the calculus is done, and it would just be a bunch of algebra. And you may be able to simplify some stuff may cancel out, but it may be just for nothing. So I think WebAssign, like I was saying before, shouldn't be too picky about simplifications here. So yeah, that should be your answer for this one. All right. I'm gonna go ahead and include these drawings, and then let's see. Should I do 33? That is the question. I think I'm doing pretty good on time, so I think we have time to go ahead and do 33 real quick. So with 33, there's a couple different ways you can do it. You can just jump straight into quotient rule, or you could also rewrite this as under just one big square root, because if you have the square root of something divided by the square root of something else, you can bring that square root to the outside, something like this. And then we could do the chain rule in a similar fashion as to number 32. But instead, I think I'm just going to go through and jump straight to quotient rule to show a couple different ways of solving these problems. All right, so using the quotient rule, f prime of x should just be, all right, the derivative of the top function. Let's see, and it looks like for it's kind of funny because in avoiding the chain rule, we actually have to do the chain rule again inside of the quotient rule, because the derivative of our top function, if we let our top function be h of x, h prime of x is going to be, so we'll have, let's see, so d by dx of x squared plus 9 to the 1/2. So we'll have to subtract 1 to get minus 1/2, bring this to the front. So we'll be left with 1/2 times x squared plus 9, all to the minus 1/2, and then multiply by the derivative of the inside because of chain rule, 2x. So at least the 2's cancel. And then we end up with this. All right, so we'll have x times x squared plus 9 to the minus 1/2 minus, and then the derivative of the bottom. The derivative of the bottom is going to be similar. It's going to be let's see. So this is, if we let this be g of x, it'll be, let's see, g prime of x d by dx, x squared minus 9 to the 1/2. So we'll end up with, let's see. Yeah, it should actually be exactly the same, except we'll have, instead of x squared plus 9, we'll just have x squared minus 9 on the inside. Like this. All right. So we'll have minus, and then, oh shoot, bad. I totally forgot to multiply by the bottom function in our first term. So multiply by, let's see, I'll write it in terms of the fractions, x squared minus 9 to the 1/2. All right, minus, and then we'll have x times x squared minus 9 to the 1/2, or to the minus 1/2, times, I'm running out of room here, x squared plus 9 to the 1/2. All right, and then in the denominator, we'll just have the bottom squared. So x squared minus 9 squared is just going to be x squared minus 9. Oof, all right, and then from here, you could do some simplification, multiply some stuff out, or maybe try to get rid of those fraction powers by doing some multiplication. But I think this is a financer, and then I'm just going to leave it here like that. All right, so for that one, it probably would have been easier just to do the chain rule, but you can also do the quotient rule. All right, so I'm going to go ahead and clear these drawings, and we can move on to the next one. All right. So with this, we introduced exponential functions. So for this, we need to know the property that the derivative of e to the x is just equal to e to the x. Which is a really nice property in calculus. Makes things really nice sometimes. So with that in mind, that's basically the answer to number 34. All you have to do is factor out this constant. So we know f prime of x is just going to be 9 times d by dx of e to the x, which we just said over here. That's a nice property. The derivative of e to the x is the only function where if you differentiate it, you just get the function back. It's the same thing. So we just end up with 9 times e to the x, the exact same thing. So not too bad. All right, and then from here, we are going to make it a bit more complicated by introducing a composition of functions, where in this case, our outer function is e to the x, and our inner function is minus 9x. So to differentiate this, first thing, just take the derivative of our outer function and leave it as is. So we'll just have, so f prime of x. So we'll just have the derivative of the outer function evaluated at the inner function, which should just be the exact same, so e to the minus 9x, then multiply by the derivative of the inside, which is just going to be minus 9, like this. All right, yeah, and then you can tidy this up, write it as minus 9 e to the minus 9x. Perfect. All right. And then 36, I think I'm going to let you guys practice. It's just similar to 34, except they're tacking on an extra minus x squared for you to deal with at the end, so it shouldn't be too bad. All right. So let's look at some of these other ones. All right. Cool. So for number 37, there's a couple different ways you can do it. You can jump right into quotient rule, or you can actually do a product rule by bringing this e to the x up to the numerator. I think I'm going to do the latter. So I'm going to equate this as x times e to the minus x. And now I can use product rule instead of having to deal with quotient rule. So taking the derivative of this, so priming this, I guess, we should get, so the derivative of the first function is just 1, so we'll just be left with e to the minus x for the first term, plus the second term should just be x times, let's see, minus e to the minus x, doing quotient rule in my head, not quotient rule, doing chain rule in my head there, where this negative out front comes from the minus on the x, we multiply by the derivative of the inside. So tying this up a little bit, we'll have e to the minus x times e to the minus x, just like that. All right, and then if you were to evaluate this using the quotient rule, you should get the same thing. All right, number 38, let's see. Yeah, I think, yeah, I'll do 38. So for 38, here, you could do a similar thing where you say this is this denominator is to the first power, we can bring it up and do product rule. But for the sake of example, I'm gonna go ahead and evaluate this using the quotient rule. So to find the derivative, we'll say f prime of x is equal to, so the derivative of the top, that's just gonna still be e to the x times e to the x plus 8. Derivative of the bottom, it's just gonna be e to the x, and the 8 goes away because it's just a constant, and then the derivative of the, not the derivative of the top, the original top is just e to the x. And in the denominator, we're just left with, let's see, e to the x plus 8 all squared. All right, and then multiplying this out, we get e to the 2x plus 8 times e to the x plus e to the 2x, all divided by, let's see. I'll just write this as e to the x plus 8 all squared. And then in the numerator, that simplifies to 2 e to the 2x plus 8 e to the x, all divided by e to the x plus 8 all squared. And I think that's enough simplification for that one. All right, let's see. For number 39, it's going to be very similar to some of the other ones, but instead of a linear, you have a quadratic in the power of the exponential. So you have to evaluate that chain rule a little bit differently, but it should be pretty similar. Just making sure to multiply by the derivative of the inside. All right. Cool. So now, yeah, let's go ahead and do 40. So for 40, we're given this function. So we actually have two composite functions. So we'll have to use the chain rule twice. So first doing it on the outside here. So we have this 4. So we'll bring the 4 down, subtract 1. So we'll have 4 times the inside stays the same. Shoot. 2x, and this is to the third power. Multiplying by the derivative of the inside, 9 goes away, and we'll have, let's see, minus e to the minus 2x times minus 2. Minus 2 coming from the inside function here using the chain rule again. So tying this up, we'll have, let's see, minus 2, that's plus 2 times 4, that's going to be 8. E to the minus 2x, I don't know why that looks like a 2, let me fix that. That should not, I don't know why it looks like a 3, I meant to say. It should be minus 2. And then that term will just stay the same. So this term here will stay exactly the same, like this. All right, and that should be your answer for number 40. So now we can move into natural log. All right, so for natural log, you have to know the property. So the derivative of natural log of x is going to be equal to 1 over x if you were to evaluate it using the definition, or you may have to use a different method, I forget. You should just get 1 over x if I remember correctly. Yeah, all right. So for this, we have natural log of x, but we have 9x on the inside, not just x. So this is going to be another chain rule with composite functions. So for the first part, we'll just differentiate it and leave the input the same. So we'll say f prime of x is going to be 1 over 9x, just like this formula, where the input stays the same. We can't forget to multiply by the derivative of the inside, the 9, so we just multiply by 9. And it turns out that these 9s actually cancel, and we just end up with 1 over x, like this. All right, so that should be that one. And then number 42 is going to be similar, except I don't think it'll cancel out quite as nicely, but it shouldn't be too bad to evaluate. Just using these same principles and formulas as before, so I think I'm going to go ahead and leave that one for you guys to practice. Moving on, let's see. Do I want to do number 43? 43 again, it's going to be the same idea, except you just have a quadratic in there instead of, you know what I'll do? I'll leave you guys to do 44, the quotient rule one, and I'll do 43 for you. So for 43, we're given this function. So f prime of x should just be, so 1 over the original input, so 1 over 5x squared minus 6x plus 2 times, and then the derivative of the inside is just going to be 10 minus 6. All right, and then from there, you could try and factor this, so not 10 minus 6, 10x minus 6, sorry about that. And then from there, you could try and factor this denominator, maybe cancel out some terms, but I think that this is a fine answer here. All right, so that should be it for that one, and I'll go ahead and do 45 while that's still up there. All right, haven't changed colors in a while, we'll go back to pink. So for this, now we have some a product rule with a nested chain rule. So f prime of x is going to be the derivative of the first function, which is just going to be 18x times the second function, natural log 9x, and then add. So the derivative of the second function is going to be we already did it before previously. It's going to be 1 over x. The derivative of natural log of 9x should just be 1 over x, because those 9s cancel out. And then multiply them by the original, 9x squared. We'll do a little bit of simplification. 18x natural log 9x plus 9x, because one of the x's cancel out. And that should be your answer for that one. All right, so I'll go ahead and clear these drawings, and we can move on to the next part here. All right. So number 46 is just going to be a quotient rule with natural log. So I think I'm going to leave that one for you guys to practice, and I'll go ahead and do 47. So for 47, we're asked to find the derivative. So this is actually going to be a double chain rule, kind of cool. So for f prime of x, we're going to keep the input the same for our derivative. So it'll be 1 over x to the 9th minus 2 all cubed, and multiplied by the derivative of this. So for this, we're going to do the chain rule again. So we'll have 3 times x to the 9th minus 2 all squared, and then multiplied by the inside of that function, which is going to be 9x to the 7th. Like this. So you can do a little bit of tidying up, but I'm not going to simplify it too much. So 27x to the 7th, x to the 9th minus 2 all squared, because 9 times 3 is 27, all divided by x to the 9th minus 2 cubed. Let's see, I think we can actually do some nice simplification here. Let me double check. Yeah. So 2 of these should actually cancel out. We should just be left with, if I did the simplification correctly, 27x to the 7th over x to the 9th minus 2, which it's kind of nice. All right, let's see. Let me look at what other ones we have left here. All right, let's see. I think I'm going to leave you guys to do, let's see. I'll leave you guys to do number 49. I'll do 48 and 50, and then I'll end the review session here. So let's go ahead and clear these drawings if I can. There we go. So for 48, we're finding the derivative again. So f prime of x, and this outside, it's going to be d by dx of ln x plus x all to the 1/2. So bring this 1/2 down, subtract 1, we get minus 1/2. Done this before. 1/2 natural log of x plus x all to the minus 1/2, multiplied by the derivative of the inside. We get 1 over x plus 1, like this. And I don't think there's too much more nice simplification you could do here, so I think I'm just going to leave it here. You may be able to multiply buy some, maybe a conjugate or something to get rid of some square roots or something like that. But I think this is a fine answer. All right, so simple enough. Let's go ahead and move on to number 50. Cool. All right, I'll do the last one in black. Why not? All right, so find the derivative of this function, g of x. So this is just going to be some chain rule. So we'll keep the input the same, and remember the natural log. And when you're taking the derivative of the natural log of something, the derivative is going to be 1 over the natural log of something. I just realized that my breakouts room window was kind of peeking in the entire time, so sorry about that. So we'll have 1 over the, let's see, not natural log, e to the x plus natural log x. That's not ln. There we go. Natural log x multiplied by the derivative of the inside, which is just going to be e to the x plus 1 over x. And then we can just write this as e to the x plus 1 over x, not times, divided by e to the x plus natural log of x, just like that. All right, and then there, yeah, I don't think there's too much nice simplification we can do. So yeah, that about wraps it up. These are all the problems that I was given. So and good luck on your exam. Make sure you get a good night's sleep beforehand. Make sure to eat something, whether it's breakfast or lunch beforehand. We also recommend at the Math Center eating dark chocolate before your exam, but because it helps release dopamine and helps relax you before your exam. Try not to drink too much coffee because it makes you hyper and can make you forget things during your exam. Also, make sure to start with the easy problems to kind of build momentum, maybe forget some, not forget, maybe to remember some concepts that you may have forgotten that'll help you with some harder problems. And yeah, like I said, good luck on your exam and have a great day.